9-3 Polygons, Part 1, Triangles. Alright, today's objective is to classify triangles based on their angles and their sides. A triangle consists of vertices, that's the plural of a vertex, and our vertices are A, B, and C. They also have three sides, hence the word triangles, tri meaning three. We have side AB, line segment BC or side BC, and side AC. We also have the angles, three angles, angle A, angle B, and angle C. When you're naming triangles, here's the ways you could name this triangle. You could call it triangle ABC, triangle ACB, triangle BAC, triangle BCA, triangle CAB, triangle CBA. Not quite sure what happened right there. Triangle names. There's two ways of naming triangles. You can name it by its angles, or you can name it by its side or sides. The first angle we have is acute, and that means all the angles are less than 90. So they're all small, cute little angles. Remember, cute, you think small. Cute little puppies, cute little kitties, all that good stuff. Okay, next you have your right triangles, and those are triangles that have one 90-degree angle. And you can only have one 90-degree angle, and we'll talk more about that in a little bit. Then we have our obtuse triangles, and they have only one angle more than 90, but it has to be less than 180, otherwise it's not a triangle. When I think of the word obtuse, I think of obese, which means fat. It's not real nice, but that's how I think of obtuse. And then acute is nice and small and tiny. Based on the sides, a triangle can be named. If it has all three sides are equal, that makes it an equilateral triangle. If you have two sides that are equal, do you know what that is called? It's an isosceles triangle. And that means two sides are equal. Scalene is when all three sides are different. No two are the exact same. And you can mix, or you can pair these up. So you can pair an angle with a side and get an acute isosceles triangle. You could get a scalene right triangle or an obtuse equilateral. Nah, I don't think you can do obtuse equilateral. Actually, we'll talk about that, but I don't think that'll actually work. Angle-side relationships, which is just what I was talking about a second ago. Sides opposite congruent angles are congruent. So if you have an equilateral triangle like this, that means that all three sides are the same. If the angles are the same, the sides opposite of them are the same. So here I have two angles that are the same. That means the two sides opposite of each of them are the same. That makes this an isosceles, an acute isosceles triangle. Now if the angles, then the reverse is true. The angles opposite congruent sides are congruent. So here I have an equilateral triangle, and that means that all three angles are the same. Here I have an isosceles triangle. Two sides are the same. So the angles opposite those sides will be equal. So this angle and this angle will be equal. Would you take a moment and would you name each of these triangles based on its sides and its angles? So you're going to have two names for each triangle. Pause the video. Come back when you're done. Let's see what you got. Don't forget to use your notes. Look above. See what you have. Okay, coming back. Let's see. For number one, we have two sides are the same. And to me, it looks like this is an obtuse because that top angle, if you flip it upside down, it looks like it is an obtuse. And then two sides are the same gives me an isosceles. Number two, down below that, thing jumping out at me, all three sides are the same. and the angles are all less than 90, so they're all acute. So I get an acute equilateral triangle. Number 3, up top right, I see 3 sides that are different, and I see a little square in the middle, or in one of the angles. That gives me a right scalene. And number 4, that should be obtuse scalene. Would you try these 4, please? Pause the video, see if you can do a little bit better or can get a perfect score. Okay, number 5. That looks like an acute angle up top, so I'm going to say acute. All 3 sides are different. That gives me scalene. Now down below, I have 2 angles that are equal, and remember the sides opposite of those angles are equal. So I've got acute isosceles. And here I have a right, and all 3 sides are different. Scalene. Number 8, I got another right, but I have 2 sides that are the same. That gives me an isosceles, so right isosceles. Our 180 degree rule, every triangle has angles whose sum equals 180 degrees. So when you add up the angles for a triangle, they always add up to 180 degrees, which can be helpful if you know 2 of them. So if I have angles A, B, C, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So if I have 85 degrees, 65 degrees, and X degrees, I can find X. I could start out by setting it up like this. I'm going to simplify that a bit. I did 85 plus 65 is 150, and I got X. Subtract 150 from both sides, keeping our equation balanced. X is equal to 30 degrees. Would you try these 2, please? Pause the video and then come back. So I'd like you to set this up so that looks something like this. You don't necessarily have to put the degrees or the M angle or the measure of angle X. You can just say X plus 115 plus 45 equals 180. Then add 115 plus 45, you'll get 160. Subtract 160 from both sides, keeping our equation balanced. We get X is equal to 20 degrees. So the measure of angle X would be 20 degrees. If you haven't done number 2 yet, would you try that? Still waking up? So we'll get Y is equal to plus 42 is equal to 180. Subtract 42 from both sides. We get Y is equal to 38. Any questions about that? Make sure you write them down so you can ask them when you come back in. And that's it. Please post that you watched the video on Edmodo, and we're done.